All right, so this riverboat simulation, what you're going to do, read the instruction, open the simulation, link to the image below in another tab, then answer the questions below. So we have this business, and then we have these questions. You're going to have to manipulate the simulation in order to answer these questions. So let's go through the simulation, make sure you understand how to do that. When you open that website, when you click on that link, it's going to bring you to the physics classroom, which is really great. And then you scroll down and you come to this simulator. Okay, there are lots of things going on with this simulation. First, it's a riverboat. So we have a boat and we have a river. Okay, what is true about a river? It's flowing, it's moving. So we have river speed over here. We can change the river speed. Okay, we can change the river width as well. I'm going to leave it right at 140 there. But tell me, why is there an arrow with river speed? What is often represented by arrows that we just talked about earlier? It's a vector, right? So this is one vector that you're going to be looking at today is river speed. And then we have boat speed and we have heading of our boat. So we can change those, manipulate those a little bit. But what I'd really like for you to do also is to show velocity. If I show the velocity, then I get these two arrows here. What is it that's usually represented by arrows? Vectors. So we have three vectors that are affecting this boat traveling. All right. Now, I'm not going to have you do any math, but I want you to think in your normal person brain. If I add all three of these together, I am going to get the location across the river that my boat's going to hit. So then I'm going to hit play and see what happens. I went straight across the river. Okay. What happens if, let's hit the reset button. What happens if I change my boat speed? What happens to those arrows? They shrink. They get smaller in magnitude. Let's change the boat heading. What do you notice about the arrows when we change the boat heading? They change also. They change the magnitude this way or that way. And then the speed changes the magnitude to make it larger. So if I point my boat there with the same river speed, hit play, why didn't my boat go straight across the river? Like, you guys are smart people. Why didn't my boat go straight across the river? Because the river is pushing it. So this vector of 5 meters per second added with these two vectors had me end up over here. So I want you to go through the questions that are in the lesson. The first one, for a boat heading straight across the river, how does a change in the boat speed affect the crossing time and downstream distance? So when I go to my simulation, I'm going to hit reset, and I'm just going to let it play again. Okay. I had 11.5 seconds. What if I change my boat speed? What if I go really fast? And then just hit play. My boat speed shortened the amount of time, but I got to the same place on the river. All right, what if I make my boat go really slow? Let's see what happens. Kind of got to a different place on the river, and it took me twice as long. So boat speed is going to change the effective crossing time. So I don't want to answer all the questions for you. I want you to play with the simulation, but that's how you would go about it. Look at the variables that it has in the question, play with them, and then answer your question. Now, this one, you've got to change a few variables for number 2. River width, due east, and time required is what you're looking at. So you need to write something there. And we already talked about the velocity in the simulation. So you should be answering these questions using this physics classroom simulation, which is linked above. Okay? All right, so I'm going to give you some time to do that. And when you are done with that, you should go into CK12 and do the direction lesson.